Heating Effect Due to Resistance by KayScience.com. Here we have a series circuit containing a 1.5 volt cell and a resistor. And this arrow shows how the electrons flow out of the positive terminal, flowing around the circuit using the conventional current. This electric current can be defined as the flow of charge per second. And these electrons transfer energy as they flow around the circuit. Let's now focus on how resistance causes a heating effect as these electrons flow through this resistor. These red circles with red crosses represent the positive metal cations, which are held in a fixed position and just vibrate about that fixed position. These vibrating cations cause the electrons to collide. The more the cations vibrate, the more the electrons collide with them. The less the cations vibrate, the less the electrons collide with them. Now, because current is the flow of charge per second, and these electrons transfer energy as they flow, we can calculate how much energy is transferred per second. This is the power, and we calculate the power using current and potential difference. It's question time. Attempt these questions to check your understanding. Therefore, the equation is P equals I times V. That's power equals current times potential difference. We can calculate the power using current, as current is the flow of charge per second, and we need to know how much energy is transferred per second. So current tells us this. And potential difference tells us how much energy is transferred. And power is how much energy is transferred per second. Therefore, we can use current times potential difference to tell us the power. These electrons then continue to flow around the circuit and back to the negative terminal of the cell where they complete the circuit. So what happens in the resistor is collisions of electrons with vibrating cations cause resistance. This resistance causes the temperature of the resistor to increase. These red lines represent the thermal energy being transferred into the surroundings, causing the surroundings to heat up. This heating effect is caused by the resistance due to the electrons colliding with the vibrating cations. This thermal energy then dissipates into the surroundings. So the greater the heating effect, the more power that is wasted. The lower the heating effect, the less the power is wasted. It's question time. Attempt these questions to check your understanding. There's an equation to calculate the power wasted due to heating. And this is power equals current squared times resistance. The symbol of power is a capital P and the unit is watts, where the symbol of watts is a capital W. The symbol of current is a capital I and the unit of current is amperes or amps, which has the symbol a capital A. The symbol of resistance is a capital R and the unit of resistance is ohm and has this symbol. We can write this equation just using the symbols, where P equals I squared times R. We can simplify this equation by writing P equals I times R. This equation tells us how much power is wasted due to heating. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets and quizzes at KayScience.com. And don't forget, to like and subscribe.